Okay. So regarding today morning class, I'm sorry for having the class in the morning. I actually didn't know about your admission. මොකද මම දැනන් හිටියේ පහුගිය දවස් ටිකේ admission ඔක්කොම දුන්නා කියලා. මම හිතන් හිටියේ ගොඩක් schools වල admission දීලා ඉවරයි කියලා. And sorry for the late notice. මම උදේ හැරෙනකොට තමයි මම දැක්කේ කීප දෙනෙක්ම මට private message උත් දාලා තිබ්බා that a lot of you are going to school. So there is ඉස්කෝලේ යන දවසකට මම උදේ class දාන එක it's not ethical no. So that's why I rescheduled the class for tonight. And other මේ time එක ගත්තෙත් I had another grade 10 new batch class. So ඒගොල්ලන්ගෙන් time එක පොඩ්ඩක් අරගෙන තමයි අපි මේ class එක time එක ගත්තේ because more than them doing the class for you is more important. Anyhow, it's okay. I know that mate slot එකට එන්න බැරි කට්ටියක් ඉන්නවා because most of you all have classes at this time too. But anyhow, we will record the class and I will share the recording in the group as well. Okay. So, did anybody send me any difficult questions that you wanted me to discuss on WhatsApp? මට මතක නැහැ එහෙම එවලා තිබ්බද කියලා. එහෙම එවලා තිබ්බද ඔයගලන් කවුරු හරි? You had sent. Okay, let me check. First of all, let me share the whiteboard. I was actually a bit concerned මේ වගේ time එක දාන්න මොකද දැන් ඉවර වෙන්නේ අපිට 11 නේ 11:30 නේ 11:30 කියලා තමයි මම time එක කිව්වේ but then I felt like it would be too late ඒකයි මම 11 කියලා දැම්මේ group එකේ ඊට පස්සේ Saturday class එකේ සිතුකේ කිව්වා she has a class from 6 to 11 so එතකොට මට හිතුණා 11 is not too late because some classes go till 11 no. But anyways, අපි කරගෙන යමු අපිට 11 වෙද්දී නිදිමතයි වගේ නම් we will stop. But if we can drag it till 11:30, we will try. Friday morning class is there as usual. I hope දැන් වෙද්දී නම් ගොඩක් දුරට admission ඇවිල්ලා තියෙන්න ඕනේ because Friday is too late. Has everybody gotten the admission? Has everybody gotten the admission?
අනේ තෝක වයිද චුටි පැටියෝ අයට
Okay. Admission මේ වෙදින හම්බෙලා තියෙන්න ඕනේ because Friday is anyways too late. Your exams start on Tuesday නේ. You're getting tomorrow. Okay, then no problem. කොහොම හරි මේ week එකේ ගන්න කියන්නේ උගන්ට ස්කූල් දෙනවා නම් ඔයගලන්ට මේ දැන් වෙදි හම්බ වෙලා ඇති but private applicants ලා ඉන්නවනේ. Even international schools private apply කරාට ස්කූල් එක through යන හින්දා ඔයගන්ට admissions ස්කූලෙන් හම්බ වෙනවනේ. මම හිතන්නේ නේ. එහෙම නැතු කවුරු private apply කරන කට්ටිය ඉන්නවා නම් admission තාම හම්බුනේ නැති check on that මොකද last batch එකේ මගේ එහෙම student කෙනෙක් හිටියා she was in grade 9 but she wrote O levels and grade 9 ඉඳන් O levels දෙවුවා එතකොට යාට school එකෙන් apply කරන්න බෑනේ so she applied private and her admission got very much delayed and then they had to go to like examinations department and there was this entire situation. So I hope all of you, none of you have to go through that trauma. Okay. Manisha question එකක් එවලා තියෙනවා කිව්වා. Yes, Dinugi, we will discuss a more question too. ඊට අමතරව I am planning to discuss the 2023 MCQ. We have 2 questions. Let me get these questions to the whiteboard. Okay. මේක discuss කරලා පස්සේ අපි more question එකක් discuss කරමු. I have some selected questions that I want to discuss, but if you have questions that you want to discuss, let me know. Okay. A student read a label with very small letters using a hand lens. One second. Record 11, 12, okay. හරි. මම ඒක අතරට එවන්නම් පමෝදි. Okay. So a student read a label with very small letters using a hand lens. So hand lens, this paper is, what is this paper, Manisha? මම paper එක ඔයගොල්ලන්ගේ groups වලට share කරන්නම්. Give me a second. කොහෙද paper? Let me share these to your groups. So can't take him බලන්න පුළුවන්. Saturday and Sunday නේ. මම එකක් කෙව්වා මේ question එක. Okay. No, the other question also was sent. So this is the question. A student read, okay, so hand lens එකක් කියන්නේ, is it a concave lens or a convex lens? Hand lens එකක් කියන්නේ, is it a concave lens or a convex lens? Hand lens, you know, hand lens is a magnifying glass, ne? Is it a concave lens or a convex lens? Okay, Binuti, others? Convex lens. So, let's write the answers here. What type of a lens is used as a hand lens? We know that is a convex lens. Okay, Roman number 2. Between what points of the lens should the label be placed in order to magnify the letters? කොහෙද label එක තියන්න ඕනේ? Okay, Binuti, others? Label is the object, no? So where should the object be placed to get the image in the hand lens? Lamai, when it comes to the image formed by a hand lens, is it a real image or a virtual image? If you take a hand lens, or we call it magnifying glass, or we call it simple microscope, is the image a real image or a virtual image? It is a virtual image. Why do we call it a virtual image? හැම වෙලෙම ළමයි, whether it is a lens or a mirror, mirror එක through image එක පේනවා නම් it's a virtual image. And if it's a lens, lens එක through image එක පේනවා නම් it is a virtual image. හැබැයි mirror එක හරි lens එක හරි through image එක පේන්නේ නැත්නම් you have to use a white color screen. If the image can be obtained to a white screen, then we call it a real image. Virtual image එකක් නම් mirror එක හරි lens එක හරි through පේන්න ඕනේ. එහෙම නැත්නම් it's a real image, in which case we have to use a white screen. A magnifying glass එක through පේනවනේ මට ලොකු වෙලා image එක, so it's a virtual image. Is it magnified or diminished or same size? Is it magnified or diminished or same size, the image? Of course, yes. It should be magnified because that is the whole point of a magnifying glass. The image should be magnified. Is it upright or inverted? Upright. Or object එකක් image object එකක් magnifying glass එකකින් බැලුවම upside down පේන්නේ නැහැ නේ. So it's upright. කොහොමද ළමයි මේකේ ray diagram එක එන්නේ? Let's say this is the principal axis. අපි ray diagram ගැන ගොඩක් in detail කතා කරලා තියෙනවා. So I'm not going to take too much time for that. We know it's a convex lens. This is twice the focal length. Focal length and twice the focal length. Now we know the object should be placed between the lens and the focal point. Then let's draw the rays. Parallel යන light ray එක focal point එක through refract වෙනවා. Then optical center එක through යන light ray එක ඒ path එකේම යනවා. We can see the refracted light rays don't meet at the front because they are going away and away from each other. So what we do is we extend them backwards. So මම මෙයාව backwards extend කරනවා. One second, Lamai, I can't. Give me a second. My whiteboard is getting stuck. Let me reshare the whiteboard. I have shared the whiteboard. Okay. So, since the refracted light rays are not meeting at the front, we have to extend them backwards. මෙයාව backwards extend කරාම මේ path එකම තමයි, but මෙයාවත් මම backwards මෙහෙම extend කරනවා. So you have rulers now, so you can use rulers. I don't have a ruler, so I will just roughly draw like this. So we can see they meet here. So this is the virtual image. So this is the object and this is the image. It is virtual, it's upright and it's magnified. So this is what happens in a magnifying glass, okay? Or a hand lens. So in the question, what they're asking is, between what points of the lens should the label be placed? Between what points? So, තියෙන්න ඕනේ lens එකයි focal point එකයි මැද. We have to say between what points now? So between pole and focal point. This is called the pole, right? This is called the pole. Sorry, this is called the optical center. See, optical center and this is the focal point. So we have to say between the optical center and the focal point. Huh? Between the optical center and the focal point. Roman number 3. Draw a ray diagram to show how the image of a distant object forms when the above lens is focused on it. Add the තියෙන object එකක image එකක්. Distant object එකක් නම් where do we assume the object to be? If it's a distant object, where do we assume the object to be? What should be the location of the object if we are talking about a distant object? Yes, others? If the object is a distant object, distant can ඈත තියෙන එක. එතකොට අපි normally assume කරනවා distant object එකක් කියන්නේ the object is on the at infinity කියලා. The object is at infinity. So generally when we say a distant object, that means the object is at infinity. If the object is at infinity, where is the image? Where is the image formed? How the image of a distant object, if the object is at infinity, where is the image formed? Object එක infinity තියෙන. Where is the image formed? point. If the object is at focal point, image is at infinity. If the object is at infinity, image is on the focal point. ඒක අපි කොහොමද ray diagram එකක පෙන්වන්නේ? We don't have to like draw a very complicated ray diagram. We can draw something simple like this. So here I have a convex lens. And this is the principal axis. So parallel light, so infinity වලින් එන්නේ ඔක්කොම parallel light rays, right? So infinity එකෙන් parallel light ray එකක් එනවා and their focal point එකෙන් refract වෙනවා. So this is the focal point. Another parallel light ray comes from infinity. එයාත් focal point එක through refract වෙනවා. So ඔන්න ඔහොම තමයි distant object එකක image එක හැදෙන්නේ. Focal point එක උඩ තමයි හරියට මේගොල්ලන් refract when, because always when the object is at infinity, we consider that parallel light rays are coming. මොකද parallel lines නේ හැමලෙම infinity වෙනකන් යන්නේ. So if the object is at infinity, parallel light rays are coming. When parallel light rays are refracted from a convex lens, they go through the focal point. Then, so that is the ray diagram. Simple as this. මීට වඩා complicated වෙන්න ඕනේ නැහැ. මේකට අපි ලොකු ray diagrams ඉගෙනගෙන නෑනේ. So මේ වගේ ලොකුට ray diagrams ඉගෙන ගත්තේ නෑ මේකට. So you just draw something like this. B. Write down two features of that image. If the object is at infinity, image එකේ මොනවාද properties? What can you say about the size of the image? No. Not magnified. It is diminished. So, object එක focal point එකේ තිබ්බොත් image එක තියෙන්නේ infinity වල. Then we know the image is real, magnified, and inverted. If the object is at infinity, image එක හැදෙන්නේ focal point එකේ. ඒතර බලන්න object එක දුර වැඩි, image එක දුර අඩුයි. So here this image will be diminished real and inverted. These are the properties of that image. Diminished, real, and inverted. එක පොඩ මතක තියාගන්නමයි. So, two features නේ. So මේ තුනෙන් මොකක් හරි එකක් ලියවනම් ඇති. Real, inverted, diminished. ඔගාන මතකද ළමයි අපි අර මේ lab එකේ කරේ experiment එකක් නේ පොඩි activity එකක්. We chose a window and through that window we need to get a distinct object. හොඳට පේන object එකක් ගන්නවා ඈත තියෙන. So එතකොට ඈත තියෙන හින්දා අපි assume කරනවා object එක තියෙන infinity. එතකොට යාගේ image එක අපි lab එකේ මෙහෙම lens එක තියලා මැද white color screen එකක් තියලා ඒ white color screen එකට අපි image එක ගත්තා. හිතන්න ඈත ගහක් කියලා object එක. So object is at infinity no. So that object is, let's assume it's a tree. A size එකටම මගේ screen එකට image එක හැදෙයිද? ඒ tree එකේ size එකටම ලොකු image එකක් එන්නේ නැහැ නේ. So tree එකේ size එකට වඩා පොඩි image එකක් තමයි මගේ screen එකට එන්නේ. Do you remember that activity ළමයි? The activity we used to find the focal point of a convex lens? Others? Give me a thumbs up if you remember that activity. The මතක නැත්තම් මොකද කරන්නේ? You have to go through that, ඒකේ කරේ object is at infinity. අපි assume කරා ඈත තියෙන object එකක් ගහක් වගේ එකක් අරගෙන convex lens එකක් තිබ්බා, screen එකක් තිබ්බා. We moved them back and forth and we tried to get the image of that object to my white color screen. White screen එකට ගන්න පුළුවන් කියන්නේ it's a real image. ඒක ඔයගොල්ලෝ මතකද upside down තමයි image එක හැදුනේ. So it's inverted. And obviously, it's not the same size as the tree. The tree is huge, but this image is small, so it's diminished. A activity ka matak kuna na make answer ka ganna puluwa. Then C, mention the type of mirror that can be used to obtain an image with the features mentioned above. May features වලින් image එකක් ගන්න පුළුවන් mirror එක මොකක්ද? Is it a convex mirror or a concave mirror or a plane mirror? Those are the only three types of mirrors we have learned. Concave mirror. Always remember, Lamai, concave mirror and convex lens are kind of similar. Convex mirror and concave lens are kind of similar. Now, this is a convex lens now. Convex lens eකට similar විදියට images හදන්නේ mirrors වලින් concave mirror. So the answer is concave mirror. Up to that point, is it clear to everybody? Give me a thumbs up. Others? All right. Let's move on to B part. The diagram given below shows how an electric kettle with a metal cover is used for boiling water in a house. Mention the wires that are compulsorily found in the cable denoted as X. X කියන cable එකේ අනිවාර්යයෙන්ම මොනවාද තියෙන wires in this X cable? Compulsorily found. That means they must be there. මොනවාද? Cables හැදිලා තියෙන wires මොනවාද? ළමයි? Live wire and neutral wire. Current යන්නේ නැහැ live wire එකයි neutral wire එකයි නැත්තම්. Anywhere current comes from the live wire and current leaves from the neutral wire. Earth wire එකක් තියෙනවා, but not always, right? Because of course we have some instruments which have two pin plugs. Two pins කියලා කියන්නේ live එකයි neutral එකයි විතරයි තියෙන, earth එක නැහැ. Three pins නම් තමයි උඩ earth එක තියෙන්නේ. So compulsorily තියෙන live wire and neutral wire. Earth wire may or may not be present. Okay? Write down the energy transformation that occurs in the kettle. මොනවාද ලිව්වේ? ඔයගලන් sorry. This is a question we are discussing now. What do you think? What is energy transformation in a kettle? Quickly tell me. You can get the answer. මේව දන්න ඕගොල්ලන්. Okay, Akif? Obviously, අපි current supply කරනවා, so there is electrical energy, right? And that electrical energy is used to heat water, so electrical energy is converted to heat energy here. Then Roman number 3. The values 230 volt and 1000 watt are marked on the kettle. What is meant by 1000 watt? What is the meaning of 1000 watt? Watt කියලා කියන්නේ මොකක්ද ළමයි? Is it voltage or is it current or is it energy? What is watt? What is measured by watt? What is measured by watt? Power. And what is power? Power is work done divided by time or energy divided by time. දැන් මෙතන work done නෙවෙයිනේ සාමාන්‍ය kettle එකකදී අපි කතා කරන electrical energy නේ. So මෙතන 1000 watt කියලා කියන්නේ this is the electrical energy consumed by the kettle within 1 second. That is what is power, no? Because power is electrical energy divided by time. Electrical energy divided by time means the amount of electrical energy consumed by the kettle within 1 second. That is power. Then Roman number 4. How much is the amount of energy required to boil 1 kg of water at 30 degrees Celsius up to its boiling point when this kettle is used? So we of course use Q equals MC theta here. The mass of the water is 1 kg. Specific heat capacity is 4,200. And temperature is, now it is at 30 degrees Celsius, but it is heated up to the boiling point. And what is the boiling point? What is the boiling point? Alamai? 100. Then what is the temperature change here? Because theta is temperature change. What is the temperature change I should put here? Okay, others? Everybody answer. It is at 30 degrees Celsius. It will be heated up to 100. So the temperature change is 70 degrees Celsius. Yes. So we will multiply 42, 7 ke multiply karna. So 7 times 2 is 14. 1 remaining, 7 times 4 is 28 plus 1, 29. Methana zeros dekai, methana zero ekai. So altogether 3 zeros. So you know energy is measured in joules. 294,000 joules. Then fifth Roman number. Mention a physical property of each of the material used for manufacturing heat coil and part Y of the kettle. Mention. Lama, can you hear me? Give me a thumbs up, please. Okay. I actually got disconnected. So let me share the whiteboard again. Okay. I have shared the whiteboard. For those of you who cannot see it, I will send the link in the main chat now. Okay. So, api kotanda kata karati okay, this calculation, ne? So, 42 multiplied by 7. So, 7 times 2 is 14, 1 remaining. 7 times 4 is 28 plus 1, 29. And 0, 0, 0. So, 294,000 joules. Then Roman number 4. 5. How much is the time taken to boil water? How much is the time taken to boil water, lamai? කොහොමද අපි එක හොයන්නේ මෙතන? Balanda, you know electrical energy is converted to heat energy, right? Electrical energy is converted to heat energy. If the heat energy was 294,000 joules, what is the electrical energy that was given to this? If heat energy was 294,000 joules, what is the electrical energy that was given to this? Electrical energy thamai heat energy වලට convert වෙන්නේ. So if the heat energy is 294,000, the electrical energy that was given also is 294,000. Now we know power is equal to energy divided by time. Now energy is 294,000. Time we don't know. Power, they have given the power as 1000 watts. So power is 1000 watt. So mama T එක මෙතනට ගෙනලා 1000 මෙතනට ගෙනවා. So T is equal to 294,000 divided by 1000. So may zeros to cancel vela. I get the time as 294 seconds. Is that clear to you, Lamai? Others? Okay. If anybody has any questions, let me know. Can you explain the third Roman number? Third Roman number. Got third question, Nico? Values 230 watts and 1000 watt are marked. What is meant by 1000 watt? Now we know what can power ne? Power is energy divided by time. So කොහොමද අපි මේක energy divided by time කියන එක ලියන්නේ? Power is the energy consumed. One second. Power is energy consumed in a unit time. Power is the energy consumed in a unit time. Power equals energy divided by time. Can I copy liyan? Power is the energy. Oh my god. Gamai, I'm sorry. My connection is a bit bad today. Can you all hear me? It took some time for me to change the network and log in again. Mama, hello, the Lamai Ogolanta. Can hear, no? Okay. Let me share the whiteboard again. I have a very bad connection issues today, so I changed my network. We'll see if it gets better. One second. Okay. I have shared the whiteboard again. For those of you who cannot see it, I will send the link in the main chat. Hurry. I hope I won't get disconnected again. So, power is energy divided by time. Energy divided by time power is energy consumed in a unit time. And a equation, if I wrote it in words, I would write like this. Power is energy consumed in a unit time. That is why we say power is energy divided by time. Is that clear, Manisha? Yes. The unit time I can take it as 1 second. So 1000 watt that is the energy consumed within 1 second. Because energy consumed within 1 second is the same as power. That is why I wrote it like that. Okay. So this part is clear to all of you, right? Mention a physical property of each of the material used for manufacturing heat coil. and part Y of the kettle. This is a very උඩ අපිට මොකද ඒක ගැන details දීලා නැහැ නේද? How an electric kettle with a metal cover is used for boiling water in a house. Part Y. Part Y is the handle, no? So handle එක මේගොල්ලන් metal ද නැද්ද කියලා කියලා නැහැ. Mention a physical property of each of the material used for manufacturing heating coil and part Y. හරි. Heating coil එකේ physical property එකක් කියන්න. What should be a physical property that the heating coil should have? Heating coil එකෙන් කරන්නේ අර electricity එද්දී අර රත් කරනවා. Then from that heat only the water will heat up. So what is a physical property of the material used for the heating coil? Don't you think that it should be a good heat conductor? Do you think that it should be a good heat conductor? Heating coil එක හදලා තියෙන material එක, it should be a good heat conductor. Do you agree with me? Yes or no? Alamai? නිදිද ඔයගොල්ලෝ? Material used for heating coil should be a good conductor of heat. Okay. What do you think about this? Why can මෙතනම handle එකනේ? Handle is what we use to hold the kettle. Usually O levels වල නම් මීට වඩා ටිකක් specifically question එක අහනවා. But මේ question එකත් අපිට answer කරන්න බැරි නැහැ. If you take the Y part is what we use to hold the kettle. Do you think it should have a good heat conductivity? Do you think it should be a good heat conductor? Why? As in the Y part. The handle part, do you think it should be a good heat conductor? Okay. Others? Absolutely not. Why? If it's a good heat conductor, එයාත් රත් වෙනවා. මට ඔක handle එකෙන් අල්ලගන්න බැරි වෙනවා එතකොට, right? So, material used for Y is not a good conductor of heat. මේ question එකට අදාළව අපිට physical properties කියද්දි ওই දෙක තමයි කියන්න පුළුවන් mainly. I mean, other than that, we can't say much. No, අපි දන්නේ Y කියන එක නේ හැදලා තියෙන්නේ plastic වලින්ද, සමහර electric kettles වල අර ලස්සන aesthetic kettles වල wooden covers උත් තියෙනවා. So අපි දන්නේ Y මොනවෙන්ද හැදලා තියෙන්නේ කියලා. So ඒකින්ද අපිට ගොඩාක් specific answers ලියන්න බෑ, but when it comes to the conductivity of heat, we can say that obviously the heating coil should be a good conductor of heat, but Y should not be a good conductor of heat because we have to hold the kettle from Y. Which is the plug suitable for supplying electricity to the kettle? 2-pin or 3-pin plug? Give reasons for your answer. 2-pin the 3-pin the. Alamai? 3-pin. Why 3-pin plug? If there's an electric leak, if there's an electricity leakage or short, the extra charges will be earthed by the earth wire. Earth wire එකක් තියෙන්න ඕනේ. leak වගේ වෙනකොට එම ඒකෙම earth වෙන හින්දා අපිට කිසි damage එකක් වෙන්නේ නැහැ. So generally a 3-pin plug is the most advised one. Okay. Any other questions in that in this question? Any doubts? Any concerns? Anything that you didn't understand? Clear. Others, give me a thumbs up if all is clear. ආයක තව question එකක් තිබ්බනේ. Okay, great. Let me get that question. A diagram of a blast furnace. I love blast furnace. Extraction of iron is one of my favorite parts in the syllabus. Ninth question. A diagram of a blast furnace used for iron extraction is shown here. Okay, blast furnace එකක් තියෙනවා, waste gas යනවලු. My connection is not very stable, so I will keep my camera off for some time. We have compressed hot air, A, B, C, D, E කියලා parts තියෙනවා. So this is the blast furnace we have. Okay. A, Roman number 1. One component of the mixture entering from point A. One component of the mixture entering from point A is hematite. Point A වලින් දාන materials කියලා කියන්නේ raw materials ටිකනේ. So one of them is hematite. What are the other two components? What are the other raw materials? Okay. Yes. We have altogether 3 raw materials for extraction of iron: coke, limestone, and hematite. So since hematite is mentioned, other than hematite, apita coke and limestone තියෙනවා. Those are our other raw materials. Why fire clay bricks are used to make B? B කියන්නේ මේකේ wall එකනේ. මම ඒක ඔයගලන්ට කියලා දීලා තියෙනවා. B is the wall, and this wall is made from fire brick. Why is that? ඇයි fire brick වලින් හදලා තියෙන wall එක? ළමයි? Have you seen දර පෝරනුවක්? ඒ කියන්නේ ඔය bricks වලින් හදපු oven එකක්, not like the electric oven. Bricks වලින් හදපු oven එකක් දැකලා තියෙනවා නම් ගොඩක් වෙලාවට ඔය ovens හදන්නේ fire bricks, ගිනි ගඩොල් වලින්, right? ඒකේ වෙන්නේ when there is heat inside, when there is a certain temperature inside, that heat they will keep it inside. If you take the blast furnace, you know the temperature is around 1000 to 1900 degrees Celsius. මේ heat එක එළියට යන්න දෙන්නේ නැතුව ඇතුළෙම තියාගන්නවා මේ fire brick wall එකෙන්. So fire clay bricks use කරන්නේ to keep the temperature inside high, to maintain a high temperature inside the blast furnace. Then Roman number 3. The temperature inside the blast furnace is higher than the temperature of the hot air entering through C. Explain the reason for this. So hot air is sent from C, but its temperature is 650 degrees Celsius. But we know inside the blast furnace the temperature is 1000 to 1900 degrees Celsius. So how is it possible that the temperature increased here? What is the reason for this? What is the reason for this? Okay, others, what do you think? මේක ළමයි. So මේ question එක නම් ඇත්තටම හොඳ question. What is this paper, Manisha? Which paper is this? මම heat question එකටත් කැමතියි ඇත්තටම. It's a very interesting question. Is it like a school science seminar paper? Okay. That question is good. RIS කියන්නේ Royal Institute? What is RIS? Royal Institute or Royal International School. Okay. मैं paper का सामने होता है. Generally, I don't really like school papers much because done है मैं कितने टिको में दिखेला. But generally, school papers have it all messed up. අපේ ඔළුවත් එතකොට විකාර වෙනවා. මම මේක සාමාන්‍ය හොඳ paper එකක්. Temperature inside the blast furnace is higher than the temperature of the hot air entering through sea. That is because lamai. Now we know there are several reactions happening in the blast furnace. Some of these reactions are exothermic. What is the meaning of exothermic? What is the meaning of exothermic? Alamai? Exothermic means they release energy. So energy could be heat, mostly heat energy, but it could be any other energy too. So inside the blast furnace, some reactions are exothermic, no? So they release energy mostly as heat, and that will increase the temperature inside the blast furnace. ඒ වගේ question එකක් නම් exam එකට අහන්න තියෙන chance එක ගොඩාක් අඩුයි. මොකද අපි ඒක එහෙම හරියටම point එකට syllabus එකේ discuss කරලා නැහැ. So ඒ question එක exam එකට අහන්න තියෙන chance එක අඩුයි, but it's a good question. Roman number 4. Name the materials that are removed from locations D and E. D වලින් මොනවද අයින් කරන්නේ? D. E වලින් So, you know lamai slag. Slag floats on top of liquid iron, molten iron. Slag de උඩ ඉන්නේ. එහෙනම් D වලින් අපි අයින් කරන්නේ slag. So D is slag. E ඉන්නේ යට. E is molten iron. Molten iron means melted iron. So that means that iron is in liquid form. Name a harmful gas other than carbon dioxide present in the exhaust gas emitted from blast furnace. Carbon dioxide අරන්න වෙන මොනවාද මේකේ තියෙන gases? What are the reactions happening in the blast furnace? මම උගන්ට වෙනමයි time දෙන්න නැහැ ලියන්න. But I hope you have it in your memory now because we have discussed this so many times. Sometimes I'm even getting sick of blast furnace. අපි ඉච්චරටම discuss කරලා තියෙන මේ reactions ඒ ඔක්කොම. Coke වල carbon තියෙනවා that reacts with oxygen and forms carbon dioxide. Carbon dioxide further reacts with coke and forms carbon monoxide. Fe2O3 reacts with carbon monoxide and forms molten iron and carbon dioxide. Balance කරාම මෙන්න මෙහෙම එනවා. The limestone is calcium carbonate. Calcium carbonate will decompose forming calcium oxide and carbon dioxide. These are the main 4 reactions. Slag hadena reactions monada calcium oxide plus silicon dioxide will form CaSiO3 and calcium oxide and alumina will form CaAl2O4. These two are what we call slag. Then මෙතන carbon dioxide අරන්න වෙන මොනවද තියෙන gases? I got one answer already in the chat box earlier. Other than carbon dioxide, what are the gases that are formed here? Silicon dioxide can form වෙන එකක් නෙවෙයිනේ. Silicon dioxide will react with calcium oxide, so it is not a product. It's not produced. Yes, it is actually carbon monoxide. So මෙතන හැදෙන carbon monoxide ඔක්කොම වගේ මෙතනට එනවා, but there could be carbon monoxide remaining. And carbon monoxide is harmful. එහෙනම් මෙතන answer එක carbon monoxide. So name a harmful gas other than carbon dioxide present in the exhaust gas emitted from blast furnace, that is carbon monoxide. Then Roman number 6. Carbon monoxide oxidizes hematites in iron ore. The corresponding balance chemical reaction is shown below. Now, Dinuki said, is Dinuki there? That it's better if we discuss some more questions, which is true. මේකේ මෝල් question එකක් ටිකක් තියෙනවා. අපි ඊට පස්සේ concentration questions ටිකක් තව වෙනම discuss කරමු. But look at this one. So this is the equation for oxidizing hematite. Equation එක මම මුලින් මෙතන ලියන් ඉන්නම්. I already know the equation. Fe2O3 plus 3 carbon monoxide ගිහලා හදනවා 2Fe plus 3 carbon dioxide. So the question says mixture of iron ore fed into the blast furnace could produce 56 kilograms of iron. Iron හදන්න පුළුවන්ලු 56 kilograms. Calculate the mass of hematite contained in the iron ore mixture used here. අපෙන් අහන්න hematite වල mass එක. මම මේක කරන විදිය ඔයගන්ට කියා දීලා තියෙනවා අපිට masses connect කරන්න විදියක් නැහැ. So ඒකින් අපි මොකද කරන්නේ මුලින්ම mass එකෙන් moles ගන්න හොයාගන්න. Now here there is Fe no. If you take Fe's relative atomic mass is 56. Since the relative atomic mass is 56, එයාගේ molar mass එක මොකක්ද? If the relative atomic mass of Fe is 56, what is the molar mass? Alamai, what is the molar mass? Yes, that is 56 grams per mole. එහෙනම් N equals MOM දානවා. The mass given is 56 kg. 56 kg is 56 kilograms, no? එතකොට ඒක grams කරන්න කොහමද? I have to multiply it by 1000. So I get 56,000 grams divided by 56 grams per mole. So 56 cancel unama, I get 1000 moles. So therefore Fe there are 1000 moles. If there are 1000 moles of Fe, how many moles of Fe2O3 are there? If there are 1000 moles of Fe, how many moles of Fe2O3 are there? බලන්න මෙතන ඉස්සරහ තියෙන 1 is so 1:2 ratio එකෙන් තමයි Fe2O3 and Fe ඉන්නේ. 1:2 ratio. Then if Fe is 1000 moles, how many moles of Fe2O3 will be there? Others? Okay, others? Yes. 1:2 ratio, therefore මෙතන 1000 නම් මෙතන 500. So, මම Fe2O3 වලට වෙනම හදන්නම්. First of all, I have to calculate the molar mass. එක Fe එකක් 56, so Fe2 means 56 multiplied by 2. එක oxygen එකක් 16, so 3 oxygen means I multiply by 3. So මෙතන 56 times 2 is 112, 16 times 3 is 48. Add කරාම I get 160 grams per mole. So N equals M over M දානවා. Now if Fe2O3 moles ගාන 500 moles. Mass එක I don't know. Molar mass එක 160 grams per mole. මේ දෙනා multiply කරාම mass is 5 times 16 is 80, 0, 0, 0. 80,000 grams. That would be 80 kilograms of hematite. Is that clear to you, Lamai? So that is the last question of the A part, ne? So everything in A part, lamai mage connection podak unstable kila pennune hinda ma camera off kala tiyanne. I will try to switch it on in a bit. Huh? Anyways, in the A part, is everything clear? Please give me a thumbs up. Okay, then let's move on to the B part. B එක මම මෙතන හදා. The diagram of a simple device made to detect pieces of metal with magnetic properties is shown below. When a magnetic material is dropped from top to bottom through the copper coil. So magnetic material එකක් මේ copper coil එක through drop කරද්දී the LED will flash and then turn off instantly. So magnetic material එකක් කියලා කියන්නේ a magnetic material always has a magnetic field, right? Yes, Dinugi. Okay, no problem. I will post it in the group. So magnetic material එකක් කියන්නේ a magnetic material has a magnetic field, right? So එතකොට, do you remember in electromagnetic induction we talked about this? We said if the coil is moving and the magnetic field is stationary, a current will be created. Again, coil එක magnetic field like a stationary, coil like a moving now, there will be a voltage created, we called it induced electromotive force, and there will be a current created, we called it induced current. It can coil like a move or magnetic field like a stationary. එහෙම නැත්නම් magnetic field like a move or coil like a stationary. එතනත් electromagnetic induction වෙන්න පුළුවන්. So here now the magnetic material is moving down, but the coil is stationary. The coil is the conductor now. Meya stationary. Habai magnetic material එක පල්ලෙහාට වැටෙනවා. So the magnetic field is moving. Magnetic material is what gives the magnetic field. Therefore, here electromagnetic induction happens. Okay. Method electromagnetic induction. So what is the name given to the phenomenon? That is electromagnetic induction. Okay. Then write the energy transformation that occurs here. What is energy transformation that occurs here? Alamai? මේක නම් ඔයගොල්ලන්ට ගොඩක් පැටලෙන chance එකක් තියෙනවා. So there's a very less chance මේ වගේ question එක exam එකේ අහන්න. මේක move වෙන හින්දා ඔයගොල්ලන් කියයි kinetic energy කියලා. So kinetic energy is converted to light energy කියලා. But මෙයා move වුණාට මෙතන මොකද්ද වෙන්නේ? As the magnetic material is moving, we know that magnetic field is changing. When the magnetic material is moving down, the magnetic field is changing. එහෙනම් මෙතන වෙන්නේ magnetic energy තමයි electric energy වලට convert වෙන්නේ. Okay, so magnetic energy is converted to electric energy, not kinetic energy. ඒ වගේ question එකක් නම් සාමාන්‍ය exam එකේ අහන්නේ නැහැ. මොකද ඒක ටිකක් පැටලෙනවානේ. So different students can understand the question in different ways. Potential energy මෙතනට ගන්න බෑනේ. So if you remember potential energy, well, we talked about two types of potential energy, right? Potential energy, well, there were two types. Gravitational potential energy, again height එක. So ඒක අපි calculate කරන්නේ mass into gravitational acceleration into height. Then there is also elastic potential energy. So මෙතන මෙයා උඩ ඉඳන් පල්ලෙහාට වැටෙන හින්දා මෙයා උඩ ඉන්නකොට potential energy තියෙනවා. But as it's moving down, potential energy is converted to kinetic energy කියන එක ලිව්වට වැරදි නෑ. I mean, that makes sense, no? So here, in this case, මෙයා මෙතන උඩ ඉන්නවා. ඊට පස්සේ ආ පල්ලෙහාට වැටෙනකොට උඩ ඉන්නකොට යාට potential energy තියෙනවා. But as it's moving down, it's converted to kinetic energy. හැබැයි මෙතන, I mean, ඒක ලිව්වොත් කාටවත් වැරදි දාන්න බෑ. But දැන් මෙතන LED එකක් පත් වෙනවානේ. එතන as the magnetic material is moving, magnetic energy is changing. There's a magnetic energy, and that is converted to light energy. අන්න ඒක අර ඒ වගේ there could be more than one possible answer. So හැමෙම සම්න exam එකේ නම් අහන්නේ නැහැ. Anyways, we'll write the answer. Magnetic energy to electrical energy. ඔයගලන් kinetic energy to electrical energy, potential to kinetic ඒවා ගාලි වට නම් වැරදි දාන්න බෑ. This is the most the best answer, but අනිත් ඒවාත් answers තමයි. Okay, Mione. Then Roman number 3. What is the main reason for not lighting the LED when some magnetic materials are dropped through the coil? What is the main reason for not lighting the LED when some magnetic materials are dropped through the coil? The magnetic materials drop karnakotta, the magnetic field is changing. Then there is electromagnetic induction, so the LED bulb should light up, no? හැබැයි සමහර වෙලාවල මේ bulb එක light වෙන්නේ නැහැලු. Why do you think, what is the reason for that? What is the reason for that? Some materials will, when some materials are falling, the LED will light up. But when other materials are falling, the LED bulb will not light up. අහන්නේ ඇයි කියලා. මෙතන ළමයි, when the magnetic material is falling down, the magnetic field is changing. එතන electromagnetic induction වෙනවා. Right? So therefore, මෙතන voltage එකක් හැදෙනවා. ඒ හැදෙන voltage එකට අපි කියනවා induced electromotive force. There is also a current produced. We call it induced current. may induce electromotive force, that is the voltage that will be present between the LED, across the LED. LED කියන්නේ ළමයි diode එකක්, right? So diode එකක්, especially if it's a silicon diode, එයාව forward bias කරන්න minimum කොච්චර voltage එකක් ඕනේද? If it's silicon, in order to make it forward bias, what is the minimum voltage that is required? 0.7 volts. මෙතන හැදෙන induced electromotive force එක, if it is less than 0.7 volts, the diode will not be forward biased and the LED will not light up. Habei, if the induced electromotive force happening here is greater than 0.7 volts, now then the diode will be forward biased and the LED will light up. So ඒකයි සමහර ඒවා දාද්දි LED එක light වෙන්නේ නැහැ. So ඒක අපි ලියන්න ඕනේ. If the induced electromotive force is less than the voltage needed to forward bias, the LED will not light up. Up to that point, is it clear to all of you? Please give me a thumbs up. Others? Okay. What is the main reason? Write a change that can be. Okay, third dekane. Okay. So third එකේ මං කිව්වේ දැන් මෙතන magnetic material එක දානවානේ. දැම්මහම now the conductor is stationary but the magnetic field is moving. When the conductor is stationary and the magnetic field is moving, we call it electromagnetic induction. එතකොට මෙතන voltage එකක් create වෙනවා and මෙතන current එකකුත් create වෙනවා. So the voltage created, we call it the induced electromotive force. The current created, we called it the induced current. Up to that point, is it clear? Yara? Hari. LED is a diode, right? LED can a diode. LED stands for light emitting diode. If this diode is made of silicon, then diode එකක් through current එකක් යන්න නම් we have to make it forward bias, no? If it was reverse bias, current එක යන්නේ නැහැ. So forward bias වුණොත් විතරයි current එක යන්නේ. Silicon වගේ diode එකක් forward bias කරන්න, what is the minimum voltage required? 0.7 volts. එතකොට මෙතන induced electromotive force is the voltage, no? If that voltage created is less than 0.7 volts, මෙයා forward bias වෙන්නේ නැහැ. So then the LED will not light up. But if this induced electromotive force, again දැන් මෙතන create වෙන voltage එක, if it is greater than 0.7 volts, may LED diode එක forward bias වෙලා LED එක it will light up. Is it clear, Yara? Okay. අපි දැන් කතා කරගෙන හිටියේ ඒකනේ. Okay, so Roman number 4. What is the write a change that can be made to increase the sensitivity of this device? මේ device එකේ sensitivity වැඩි කරන්න what can we do? අනයි සාමාන්‍ය මේ වගේ එකක you can increase the sensitivity by increasing the number of coils. A copper coil එකේ මේ windings ගන්න වැඩි කරාම this will be more sensitive. We can also increase the sensitivity by increasing the speed of this magnetic material falling. And yes, we can use a stronger magnetic material. They make a magnetic of the mukad can but whatever this magnetic material is, if I use a stronger magnetic material, then the device will be more sensitive. So clear what we can do is increase the number of windings of the coil. Anitaka tamai, what did I say? Using a using a stronger magnetic material. So you get marks. Fifth, name another device that operates on the same principles of generating electricity as this device. May device with the electricity generate devices. Excuse me. What are the other devices? Yes. Electromagnetic induction examples alternating current dynamo, which is AC dynamo, then bicycle dynamo, and what else? Moving coil magnetic microphone, no? Electromagnetic induction, those are what we learned, no? Yes or no? Yes. And may same principle operate when a device you can write AC dynamo or bicycle dynamo or moving coil magnetic microphone. That is all for the B part. Before we move on to C, do you all have any questions or is everything clear? Give me a thumbs up. Okay, then let's move on to the C part. The figure shows an electronic structure. Ninth question electronics electromagnetism part electrochemistry. Papers electrochemistry. But structure different the paper is good. I like this paper. The figure shows an electrical circuit in which 3 bulbs are connected, each with a resistance of 12 ohm. What is equivalent resistance? So, are these connected in series combination or parallel combination? Of course, it's parallel combination. And a common equivalent resistance 1 over R equals 1 over R1. R1 can make 12 and 2 number 12. So 1 over 12 plus 1 over 12 plus 1 over 12. So they have a common denominator. 12, 12, 12. So numerators are at 1 plus 1 is 2, 2 plus 1 is 3. So 3 over 12. I do cross multiplication. 3 times R is equal to 1 times 12 is 12. Yes. So R is equal to 12. This 3, when I bring it to other side, becomes division. So 12 divided by 3 is 4 ampere. Sorry, 4 ampere, 4 O. Is this clear to you, Lamai? Give me a thumbs up if it's clear. 4O. Okay. Next question. If the cells provide a 12-volt supply, within 12-volt supply calculate the current. So that's pretty easy. We have to use V equals IR. Now the voltage is 12 volts, Nene. Current I don't know, but the resistance is 4 ohm. So current is equal to 12 divided by 4. 12 divided by 4 is 3 amperes. Is that clear to all of you? Roman number 3. Name two physical quantities related to electricity that increase when the number of cells increase. Name two physical quantities related to electricity that increases when the number of cells increases. Number of cells can have dry cells. Dry cells are you know one of the very Yes, dry cells වැඩි වෙන්න voltage එකත් වැඩි වෙනවා current උත් වැඩි වෙනවා. හිතන්න දැන් මෙතන මේ dry cell එකක් 6 volt කියලා so දෙකක් ඉඳ 12 volts. තව තුනක් දැම්මොත් 18 volts. හතරක් දැම්මොත් 24 volts and so on, right? So name two physical quantities related to electricity that increase when the number of cells increase. That's the which question? Third one, no? එකක් තමයි voltage එක අනිත් එක current එක. Okay. Any questions? Any doubts in this question, Lamai? Okay. එහෙනම් we will move on. අපි පොඩ්ඩක් discuss කරමු 2023. I'm not gonna hold you till very late ළමයි. මේ දවස්වල නම් I don't know if you stay till very late. මේ දවස්වල පොඩ්ඩක් කමක් නැහැ but Monday Tuesday's exam no. Sunday Monday වගේ ඉඳන් නිදි මරණ එක නවත්තන්න. මොකද ඊට පස්සේ ඒක හුරු වුණාම ඒක sleep cycle එක වෙනස් වෙනවා ඔයගොල්ලන්ගේ right exam එක කාලෙම රැට නිින්ද ගියේ නැත්නම් it's a problem you have to always write the exam with a fresh mindset මම අන්තිම දවසේ ඔයගලන්ට කියන්නම් exam එක දවසට කොහොමද how do you behave what do you do on the exam day before the exam and after the exam right ඊපස්සේ ඊට කලින් දවසේ රෑ කොහොමද මොනවද කරන්නේ ඒ ටික ඔක්කොම මම last day එකේ කියන්නම් Saturday, Sunday classes දෙක දවස් දෙකේ කියන්නම් ඔයගලන්ට right? Okay. Shall we jump to the 2023 MCQ? Because I'm pretty sure I asked you all to do the 2023 MCQ. Twenty-three. Mama, hammer question I discuss කරන්න නැහැ because not all of these are difficult. I will discuss a few selected questions. Let's come to this 11th question. MCQ එක ළමයා. MCQ එක අපි ඔක්කොම ටික discuss කරගෙන යමුද? ලේසි ටික අපි ටක් ගාලා discuss කරගෙන අමාරු ඒවාට විතරක් we will spend some time. Let me get this to the whiteboard. Okay. Urea is an excretory product produced in. Urea produced වෙන්නේ කොහෙද ළමයි? Actually ළමයි මේක මතක තියාගන්න. Urea is produced in the liver. But urea will remove කරන්නේ kidneys වලින්. Urea is removed from the body through kidneys, but urea is produced in the liver. ඒක චුට්ට මතක තියාගන්න. What is the unit of power? Power වල SI unit එක watt. හැබැයි කොහෙවත් watt දීලා නැහැ. Watt seconds, watts per second ඒවනේ දීලා තියෙන්නේ. But nothing says watt. එහෙනම් අපි බලනවා power වල equation එක energy divided by time. We know energy is joules, time is in seconds. So we can get joules per second. So that is also unit of power. Formula for isopropyl alcohol. What is the number of atoms? So methana 1, 2, 3, 4. 4 times 2 is 8, 9, 10, 11, 12. That is 12. What is the tissue that transports food produced in plant leaves? What is it? What is the tissue that transports food? Phloem, yes. Xylem transports water and minerals. Sclerenchyma වලින් කරන්නේ support එක දෙන එක. What is cambium? ළමයි ඔයාලට මතකද meristematic වල අපි කිව්වා there are 3 types of meristems like apical meristem, lateral meristem and intercalary meristem. So එතන apical meristem එක තියෙන්නේ ඔක්කොම root apex එකේ shoot apex එක. Right? එතකොට root apex එකේ ඉඳන් යටට grow කරනවා, shoot apex එකේ ඉඳන් උඩට grow කරනවා. Intercalary meristem එක තිබේ nodes වල. So they increase the length of the internode. Lateral meristem එක තිබේ parallel to the longitudinal axis. What they did was they increased the diameter of the plant. Cambium is an example for lateral meristem. Lateral meristem වලට example එකක් තමයි cambium කියන්නේ. They increase the cross-sectional area or the diameter of the plant. When two objects are rubbed together, one of them gets positively charged, transferred to the other. Then එක rub කරද්දී එක්කෙනෙක් positive වෙනවා නම් අනිත් එක්කෙනා negative නේ. එහෙනම් මෙතනින්ද මෙතනට මොනවද ගිහිල්ලා තියෙන්නේ? Electrons. Because you know protons and neutrons cannot move, they are in the nucleus. Electrons are the only things that can move. So electrons. Acidic oxide, amphoteric oxide and a basic oxide. මේකත් අපි ඕන තරම් කතා කරලා තිනවා third period එක ගත්තොත් එහෙම we have sodium oxygen එක sodium oxide, magnesium with oxygen magnesium oxide, aluminium with oxygen aluminium oxide, silicon with oxygen silicon oxide, මෙතන P2O5, here SO3 and here Cl2O7. And there is argon, but of course argon doesn't react with oxygen because it's a noble gas. අපි මේ ඔක්කොම කතා කරා. This is weak, no, strongly basic. MgO is weakly basic. Al2O3 is amphoteric. SiO2 is very weakly acidic. P2O5 is weakly acidic. SO3 is strongly acidic. And Cl2O7 is very strongly acidic. In addition to that, there's also carbon dioxide. Carbon dioxide is also an acidic gas. මේ ටික මතකයිද ඔයගලන්ට ළමයි? Do you all remember this? So what we need is acidic oxide. Acidic oxide කියලා කිව්වම SO3 is acidic, CO2 is acidic, SO3 acidic, SiO2 is also acidic. දෙවැනියට ඉන්නෝනේ amphoteric එක්කෙනෙක්. Al2O3 is amphoteric, Al2O3 is amphoteric. Then third one should be a basic oxide. SiO2 is not a basic oxide, but MgO is a basic oxide. So this is the answer. In a plant cell, blank can be called a non-living structure. What is a non-living structure? In a plant cell, what is a non-living structure? Cell wall. හරිනේ ගෙදර වටේ ඉන්න තාප්පේ වගේ. තාප්පෙට obviously පණ නැහැනේ. It doesn't have life. Plasma membrane, it is live. It's like the security guard. It controls the entry and exit of substances. Ribosomes are also live. Ribosomes වලින් මොකද කරන function එක ළමයි? මතකයි නා කියන්න බලන්න what is the function of ribosomes? What is the function of ribosomes? Yes, others? Protein synthesis. Protein synthesis can be making proteins. Synthesizing means making. What is the function of Golgi body? Quickly tell, what is the function of Golgi body? Yes. එක එක cells වලින් ළමයි එක එක ඒවා secrete කරනවානේ. ඒ secrete කරන ඒවා produce කරන්නේ Golgi වල, then ඒවා package කරලා ඒවා secrete කරනවා. So making, packaging and secretion of secretory substances, that is done by Golgi. Another morphological feature of a plant bearing the leaves with the venation. මෙහෙම තියෙන්නේ parallel venation. This is parallel venation or reticulate venation. Is this parallel venation or reticulate venation? This is parallel venation. Parallel venation තියෙන්නේ monocots ලටද dicots ලටද? Of course, monocots. So if we were to compare monocots and dicots, we know that monocots have, monocots have a fibrous root system. Dicots have a tapped root with lateral roots. Roots වලින් ගත්තොත් those are the differences. The leaf එකෙන් ගත්තොත් එහෙම monocots have parallel venation, dicots have reticulate venation. Branches ගත්තොත් එහෙම stem එක ගත්තොත් එහෙම monocots the stem is unbranched, dicots the stem is branched. And also monocots lage the stem is even, but dicots lage stem is broad at the base and එන්නේ උඩට යන narrow වෙනවා. ඊට පස්සේ seed එක ගත්තොත් එහෙම monocots have one cotyledon in the seed, dicots have two cotyledons in the seed. Flowers ගත්තොත් එහෙම monocots have trimerous flowers. ඒ කියන්නේ petals තුනයි. Dicots have tetramerous or pentamerous. Tetramerous means 4 petals, pentamerous means 5 petals. So these are some of the differences that we have talked about. එතකොට දැන් මේ parallel venation නේ, this is monocots. Presence of a taproot system, a dicots lage. Branch stem, dicots. Having one cotyledon in the seed, now that is monocot. Bearing tetramerous or pentamerous flowers, that is still dicots. Which of the following statements on electromagnetic waves is false? Do they transmit energy? Do electromagnetic waves transmit energy? They do. All waves transmit energy. අපි ගෙනගෙන තියෙනවා if you take waves, there are two types as mechanical waves and electromagnetic waves. Mechanical waves need a material medium. But electromagnetic waves do not need a material medium. Mechanical waves, again, we divide into two as, what are they? Mechanical waves can be divided into two as, yes, transverse waves and longitudinal waves. So transverse waves වල wave එක මෙහෙම ඉස්සරහට යද්දි particles උඩ යට මෙහෙම වෙනවා perpendicularly. Longitudinal wave එක ඉස්සරහට යද්දි particles මෙහෙම තමයි move වෙන්නේ. And remember, whatever the wave is, wave එක මොකක් වුණත් all waves transmit energy. Whether it is a mechanical wave or an electromagnetic wave, all waves transmit energy. හැම wave එකක්ම මෙහෙම ඉස්සරහට යනකොට energy අරගෙන තමයි යන්නේ. So where's the question? So they transmit energy කියන එක is all waves transmit energy. They travel with a speed of 3 into 10 to the power 8 ms minus 1 in vacuum. That is true. Speed is less in a material medium than in vacuum. ඒක අපි කතා කරා සාමාන්‍යයෙන් vacuum එකට වඩා air වල චුට්ටක් අඩුයි. air වලට වඩා liquids වල චුට්ටක් අඩුයි. Liquids වලට වඩා solids වල ඊටත් වඩා speed එක අඩුයි. So this is true. But this is the false one. Always remember, whether it's an electromagnetic wave or any kind of a wave, reflect unat, refract unat, monama unat, the frequency does not change. Always the frequency does not change in a wave. Okay, so that is a false statement. Which of the following statements is true about ionic compounds? Which of the following statements is true about ionic compounds? Yes. ළමයි so මම මේක කියලා තියෙනවා උගන්ට ionic compound එකක් ඉන්න පුළුවන් states තුනක් තියෙනවා. ionic compound එකක් solid විදිහට ඉන්න පුළුවන්. නැත්තම් කෙලිම melt කරලා fused or molten form එකකින් ඉන්න පුළුවන්. නැත්නම් water එක දිය කරලා aqueous form එකකින් ඉන්න පුළුවන්. Which forms conduct electricity? Solid state, fused or molten state, නැත්තම් aqueous state. Which of these forms conduct electricity? Aqueous and yes. Fused or molten state conducts electricity. Aqueous state conducts electricity, but the solid state does not conduct electricity. They conduct electricity in the solid state. All dissolve well in water. Ionic compounds generally dissolve in water, but okkoma dissolve වෙනවා කියන්න බෑ. Not everything will dissolve well in water. So that is false. They do not conduct electricity in the fused state කියන එක වැරදි because ionic compounds do conduct electricity in the fused state. So third one is the answer. Boiling points and melting points take high values. සාමාන්‍යයෙන් ionic compounds වල boiling point, melting point ඒවා ඔක්කොම ටිකක් වැඩි. Okay, let's get the rest of the questions. Give me a second. Let me get these questions. අපි 20th එකට එනකන් discuss කරලා නවත්තමු. One second, lamai, the picture is getting uploaded. Okay. මෙන්න මේ question එක තමයි මට මුලින්ම discuss කරන්න කියන්නේ පටන් ගන්න ඕනුනේ. Then I decided that we will discuss the entire paper. Following symptoms are seen in a person suffering from a disease in the respiratory system. Release of blood with cough, loss in body weight and high fatigue. Which one do you think is a disease? It's tuberculosis. සාමාන්‍ය ළමයි නියුමෝනියා වල මොකද වෙන්නේ? නියුමෝනියා වල lungs වල fluid එකක් collect වෙනවා, right? ඒතර lungs වල fluid එකක් collect වෙන හින්දා හරියට breathe කරන්න බැරි වෙනවා. Bronchitis වල වෙන්නේ bronchioles inflame වෙනවා. එතකොට again හරියට breathe කරන්න බෑ. Tuberculosis වල තමයි මේ අර lungs වල ඇතුලේ තියෙන walls ඔක්කොම damage වෙනවා. So those walls along with blood will be removed through cough. That is tuberculosis. Silicosis කියන එක හැදෙන්නේ සාමාන්‍ය construction sites වල වැඩ කරද්දී හැම ගොඩක් silicon use වෙනවා. Right? Construction work ම වෙන්න ඕනේ. Any industry where silicon is used a lot. So එතකොට silicosis silicon එක ගොඩක් contact වෙන හින්දා silicosis හැදෙන්න පුළුවන්. Questions 12 and 13 are based on the figure. In the direction shown by the arrow, which of the following flows in the external circuit? I can මේ arrow එක පෙන්වන direction එකට මොනවාද flow වෙන්නේ කියලා තමයි අහන්නේ. What? Yes, lamai. You know zinc is the anode, right? Zinc and copper ගත්තම zinc is more reactive, so zinc will get oxidized. Oxidized වුණාම zinc ions ටික solution එකට යනවා, the electrons will go to the copper. So copper metal එකක් යා electrons ගන්න කැමති නැහැ. හැබැයි solution එකේ dilute sulfuric and H+ ions ඉන්නවානේ. So H+ ions දෙකක් electrons දෙකක් අරගෙන H2 gas එක හදනවා. This is the oxidation reaction which happens at the anode. This is the reduction reaction which happens at the cathode. එතන මේක observations වල අපිට පේනවා එන්න zinc rod එක disappear වෙනවා, and also since hydrogen gas is produced, copper rod එක ළඟ you can see gas bubbles. Anyways මෙතන යන්නේ electrons. What is the cathodic reaction taking place in the bulb cell? This is the cathodic reaction. 2H plus 2 electrons, H2 gas. Which of the following statements regarding, consider the following statements regarding refraction of light. Light refracts only when it travels from a rarer medium to a denser medium. Is it true? Is the first statement is A true? It is false. Light reflects when it's going from a rare medium to a dense medium, and also from a dense medium to a rare medium. So refracts only when it travels from a rare medium to a dense medium. Reason for the refraction is the difference in the speed of light in two media. That is true. Light ray එක bend වෙන්නේ යාගේ ඒ medium එකේ යාගේ speed එක වෙනස් වෙන හින්දා. Frequency of light changes during refraction. This is false. මම එකයි ඔයගොල්ලන්ට කලින්ම එක කිව්වේ frequency is always constant when it comes to waves, right? So only B is true. So second one is the answer. Acceleration due to gravity on Earth is 10 ms minus 2. On the moon, its value is 1 over 6 of the value of Earth. Weight of an object on the moon if it weighs 60 newtons on the Earth. අපි මුලින්ම Earth එකට බලමු. W equals mg. So මෙතන යාගේ Earth එකේ weight එක 60 newtons. Mass එක දන්නේ නැහැ. Gravitational acceleration is 10 ms minus 2. So මේ 10 මේ පැත්තට ගෙනිච්චාම division වෙනවා. So mass එක මට එනවා 60 divided by 10, that is 6 kg. Then let's go to the moon. Moon වල මොකද වෙන්නේ? Again we can use W equals mg. Mass has not changed, it's 6 kg, but gravitational acceleration has changed. 1 over 6 of the value of Earth. 1 over 6 of value of Earth, that would be roughly 10. So may 6 cancel වුණාම moon එකේ මේ object එකේ weight එක 10 newtons. Is that clear to all of you, ළමයි? 15th question and up to this point. Of the following characteristics, so the next question now, 16th one. Of the following characteristics, what are the characteristics common only to aves and mammalia? Common only to aves and mammalia. What is the answer you put? What are common only to aves and mammalia? මොනවාද ඔයගොල්ලෝ ලියපු answers ළමයි? Did you do this paper? 2023 කරන්න කිව්වා නේද ළමයි මම? Yeah, no, okay. හරි. Warm blooded බලමු. Warm blooded නම් හරි. මොකද only to aves and mammalia. කියන්නේ වෙන කටට තියෙන්න බෑ. So අපි ගත්තොත් vertebrates ලගේ මොනවාද අපිට ඉන්නේ? Pisces, Amphibia, Reptilia, aves and mammalia. Pisces, Amphibia, Reptilia, තුන්දෙනාම cold-blooded, aves and mammalia are warm-blooded. So that is a characteristic common only to aves and mammalia. Skin covered with hair කියන එක mammalia-ට හරි but aves-ට හරි නෑ. මොකද aves are birds, ඒගොල්ලන්ගේ skin එක cover වෙන්නේ feathers වලින්. Bony internal skeleton ඒක aves-ටත් තියෙනවා mammalia-ටත් තියෙනවා but අනිත් අයටත් තියෙනවා. මේ හැමෝටම bony endoskeleton එකක් තියෙනවා. So that is not a characteristic common only to aves and mammalia. Four-chambered heart is also yes. So A and D is the correct answer. Is that clear, lamai? Give me a thumbs up if it's clear. Okay, lamai. Let's wrap up from here. And Friday morning, I told you we will have another class. So එතකොට මම වෙලාව පොඩ බලලා කියන්න උගන්ට චුටක් early කරනවා නම් හොඳයි. එක දවසක් early කරන්නත් හදලා උගන්ට උදේ වැඩි කියලා I can't remember. There was something like that, no? Anyways, good afternoon anyway, but I will check the time and let you all know because these days there are a lot of classes. Even now, even today I did a lot of classes, so I also feel a bit exhausted. Because if I feel even the slightest exhaustion, I can't properly teach you. අපි මෙතනින් අදට wrap up කරමු. 2023 paper එක go through කරාම මට හිතුණා the paper is pretty good. So it's better that we discuss and 2024 එකක් discuss කරන්න පුළුවන් නම් හොඳයි. So we'll try our best to manage the time. I will send the whiteboard note. Did you all understand everything that we did today? Do you all have any questions? concerns, doubts, or is everything clear? Okay. So then we will be meeting on Friday, which is 13th. Until then, have a good time. Mama, yes, I will send the recordings. I think ඔනෙලි ඉන්නවද? ඔනෙලියන් සෙතුමිනිටත් මට යවන්න තියෙනවා කීපයක් නේ. Okay. Anyways, ළමයි. Then see you next day. Good night. And thank you for agreeing to do the class so late. But see you next day.